Hi, here is another question on circle. We are told that this is the cross section of a cylindrical log and that the point A, Y, B, X lie on the circumference of this circle and that the given chord AB is equal to 24 centimeters, the radius is 15 centimeters. The first question, we need to find out the angle AOB because we are told to show that angle AOB is equal to 1.855 radians to 3 decimal places. The first thing you can do, you can remove this triangle there, and let's remove half of it. Half of the triangle, let me call this theta, and this is 90 degrees. That's going to be equal to 15, and here we've got 12. So this is the opposite side, and this is the hypotenuse. Opposite and hypotenuse, we're going to use sine. So sine of theta is equal to the opposite, which is 12, over the hypotenuse 15. That's going to be equal to 4 over 5, and therefore we're looking at theta being equal to sine inverse of 4 over 5, which is from our calculator. So sine inverse of 4 over 5 is going to give us 0.927, 295, and so on. Now, if you were to find the angle AOB, which is this part and this part together, so this is AOB, you just simply have to have a theta here as well. So that's going to be theta multiplied by 2. So you multiply. So to find AOB, we take 2 times 0.927, 295, and so on. Let's do that. So multiply this by 2, we come into 1.85459, etc., and that's approximately 1.855 radians. And here we are, that's been shown for this one. Right. The second part, we need to find the length of AXB. AXB, so the arc length. Before we go any further, what about arc length? Arc length is r theta. So we know that arc length is going to be equal to r theta. The radius multiplied by the angle. So what is this angle here? The reflex angle. Let me find the reflex angle. So the reflex angle AOB is going to be equal to the full angle, which is 360 degrees, 2 pi, minus the angle that we know there, this angle here, which is 1.855. So let's do that. So 2 pi minus 1.855, we're getting something like 4.428. So 4.428, and it goes on. Right, so radians. Now we can find the arc AXB. Therefore, arc AXB is going to equal to r theta, which is the radius, multiplied by 4.428, and so on. And the answer to the question is 66.4 centimeters. So 2 pi, just verify this again. Okay, minus 1.855 is this much, 4.428 times 15, we're getting 66.4, and that's the answer to the question. And for this part here, the area of the shaded region. The shaded region in the book is here. Now, to be able to find the area of the shaded region, what we do, we find the area of the sector. Well, the area of sector AYBO is going to equal to half r square theta. So that means half multiplied by 1.855 to this 1.855 times 15 square. So 0.5 times 1.855 times 15 to the square, we're getting 208.6875 centimeters square. Once we know that, what we can also do, we can find the area of this triangle. And then we're going to take the sector minus the triangle. If you take this sector and you minus the triangle, you should be able to get that segment. Okay, so we take the whole sector minus the triangle. So what is area of the triangle OAB? Now the area of this triangle is very simple. You're going to use a little bit of trigonometry there. Okay, and so area of triangle OAB is equal to half AB sine C, which is here half OA times OB times the sine of angle AOB. In other words, we're saying half times 15 times the sine of 1.855. So what we're saying then is 0.5 times 15 squared times the sine of 1.855, and all of that is leading us to 107.9870897 and so on centimeters squared. Now we need the area of the shaded region. Therefore, the shaded region, area of shaded region is going to equal to 208, the area of this sector, 6.875, this sector here, take away that one, minus 107.98708, etc. So, let's do that. 208.6875, take away this, and we should be able to get 100.7004, etc. Therefore, that's approximately 101 centimeters square. This is the area of the shaded region. Okay, we're going to come to the second part of this question. Okay, coming to the second part of the question, we need to, first of all, we need to answer these questions, but then again we have to read what is in the question. As you can see, A, Y, B, C, D, A, D, C, B, Y, A, A, D, C, B, Y, A. This part here has been removed throughout its length. Remember, this is a log, okay? It's a piece of wood like this, okay? And it goes here like this, okay? And then this part here, throughout the length, this is the length, this is what they're talking about. This part here has been cut out of the wood, okay? And there we go. Okay, I don't have to make too much of a picture here, but that's it. This part here is empty now. The cross section is this. So now we have this as the cross section. We need to find the area of the cross section, if that's been removed. Okay, let me just see. How do we find the area of the cross section? Here. That's the piece of wood remaining, okay? Remember, we had this area here, and this area was 101 centimeters square. And also, what else? We are told that ABCD is a rectangle. If that is a rectangle, we can find the area of the rectangle, which is 24 by 13. So rectangle is then 24 by 13. Okay, so calculator. 24 by 13. That's going to give us 312. Together, this whole area here, is shaded completely, is going to be these two, 101, okay, plus 312. So that's come to 413 centimeters square. We need to find the area of the cross section AXBCDA. I forgot to put this AXBCDA. That's the cross section. So we want AXBCDA. So this part here, let me shade it for you. Now we want this area. So we're going to take the area of this circle minus this area. Here. So area of circle is pi r square, which is pi multiplied by, the radius was 15 centimeters square. So that's going to be 225 pi centimeters square. Therefore, the cross section that they are looking for, AXBCDA, is going to be equal to 225 pi, the full circle, minus 413. And so if we do that, 225 pi, take away 413, the answer to the question is then 293.858 and 3 and so on. So let's say 294 centimeters square. Here we are. Now this is the second part of, first part of B. Okay. Then the percentage of the volume of wood remaining. So we had this, that's remained. So if you take away this, okay, that is what is remaining, 294 piece of wood remaining. This is the cross section because that's been removed. Okay, so the percentage of that's going to be equal to 294, okay, divided by the full circle. Okay, the full circle is 225 pi. So 225 pi multiplied by 100%. That should be our answer. Not that difficult. So divided by 225 pi, and we're getting multiplied by 100. That's coming to 41.572. Okay, 452. In other words, we're saying 41.6%. So that's the last part to the question. Very interesting question. It's got many applications. Mathematics, all the chapters got plenty of applications. If you are kind of thinking of doing a career in, say, engineering, for example, you might need this. This could be a beam. When you're constructing a house, you might have to do a lot of calculations in terms of quantities, the number of packets of cement, sand, macadams that you may be required to build a house or a building for that matter. And there you go, you're going to come through a stage there where you will have to use calculations based on your mathematical knowledge. And one of those is here, like quantity surveying, it's very vast, so it's got loads of applications. The list is too long to enumerate, and therefore I'm going to leave it to you. Take care.